Hello everyone, in this video I am going to show you how to draw shear force and bending moment diagram using graphical method, and this is the example 1. So this is the beam. You can see there is a pin support and roller support. First we have to find support reactions, but in this video I am not going to find support reaction of this system because I have found it before in equation method videos. I will put the link on the description area. You can go and see there, but I will use that values for this calculation. Before we start our calculation, we have to know what are the meanings of these notations. So first, ds over dx. ds over dx means slope of shear force diagram, and ds over dx equals minus w. This w means distributed load on corresponding beam. And then dm over dx. dm over dx means slope of bending moment diagram, and this capital S means shear force on corresponding beam. We will see in calculations. So these are the meanings of these notations. Sign convention. So sign convention I will use is loads downward positive and shear force clockwise positive. Finally bending moment sagging positive. Okay, first I am going to draw shear force diagram. This is the ds over dx equals minus w. This is the slope of shear force diagram, and this w means distributed load. So as you can see, in this beam there are no distributed loads. That means this w becomes 0. That means ds over dx equals 0. Slope of shear force diagram equals to 0. When slope is equals to 0, that means it's just a horizontal line, right? If a line's slope is 0, it's just a horizontal line. That means shear force diagram will be like this. So it's set of horizontal lines, right? That's the first thing. But we have to find values. So for find values, we will use this relationship if it's needed. Okay, so this is the most simple type of problem, because for this problem I will not use this relationship. We will see how to draw shear force diagram for this beam. So starting point of shear force diagram is equal to starting point force. That means this beam is started at point A. You can see point A, there is a support reaction 4.5. So shear force diagram starting point also 4.5. It can be plus 4.5 or it can be minus 4.5. Likewise, ending point also the same. So ending point of this beam is B. At B there is a support reaction of 1.5. That means this shear force diagram will be ended at value of 1.5 Newton. So it can be plus 1.5 or it can be minus 1.5. So now I can draw all the possibilities. So these are all the possibilities. But we have to select correct answer. So for that we have to select plus value or minus value. How we do that? That's why we have a sign convention. So sign convention, it says shear force clockwise positive. So I can use this statement for selecting plus or minus. So it says shear force clockwise positive. if we take moment of this force about C or B, you can see moment due to this force is this direction. That means it's clockwise. So according to our sign convention, clockwise positive. So this is clockwise, that means our value is plus value because clockwise positive. So I can eliminate this value. Likewise, for this force, if we take moment of this force about AOC, it goes like this. So it is counterclockwise direction. So our sign convention says clockwise positive, that means counterclockwise negative. So moment due to this force is counterclockwise, that means it is negative. So our value is this value, so I can eliminate this value. Now I completely draw the shear force diagram for this beam. I will show you clear picture. So this is the shear force diagram. So I hope you understood what I said. So as you see, I didn't use this relationship for draw shear force diagram. So because this is a simple problem. Next I have to draw bending moment diagram. For bending moment diagrams, I will have to use these two relationships. So dm over dx means slope of bending moment diagram equals to shear force. So this relationship gives the values of bending moment diagram. So first I consider this AC segment. If I consider AC segment slope, I will write m1 for slope, and slope equals to shear force. So for AC segment, shear force is 4.5 Newton. So slope equals 4.5 Newton plus 4.5. So that means slope is the plus 4.5. So I can draw shape of this line is like this. It's a straight line with a slope, right? So but I don't know the values, but I know a starting point because at A there is a pin support. So pin support means there is a no resistance for moment. That means bending moment is 0 at point A. So bending moment is started at 0 and it goes like this because I found the shape of bending moment diagram. So this is a straight line with the slope, right? So this is the bending moment diagram for AC segment, but I still don't know value of this point. So for that I can use this relationship. So I will write m equals m1. m1 is the previous bending moment value. So I will consider this value. Previous bending moment value is this value. So you can say it's 0 plus area under the shear force diagram between x1 and x2. That means area under the shear force diagram between A and C. So area under the shear force diagram is this area. So I can find this area. This height is 4.5 and this length is 3 meters. Height is 4.5, this length is 3 meters. So 4.5 times 3 becomes 13.5. So finally I can write the answer as 13.5 Newton meter. So value of this point is 13.5 Newton meters. That is the AC segment. For CB segment, I will write slope as m2. It is equals to shear force. So for CB segment, shear force is minus 1.5 Newton. So slope is equals to minus 1.5. So that means it's also a straight line, but opposite direction. So it's like this. It is a straight line with a slope, but opposite direction, right? So now I can draw bending moment diagram. We know bending moment diagrams are the continuous diagrams. Unlike this shear force diagram, these are the continuous diagram. That means if previous diagram is ended at this point, next diagram will be started at this point. So I will know for CB part, bending moment diagram will be started at this point and ending at 0, because here also there is a roll support. Roll support means there is no resistance for moment. That means bending moment is 0 at point B. So this is the starting point, this is the ending point, and this is the shape. So I can easily draw bending moment diagram. So this is the complete shear force and bending moment diagram. So I will show you clearly drawn shear force and bending moment diagram. So this is the our final answer.